Alright guys, get your 3D glasses because today's class is going to be about volume. And volume is how much space in 3D, in 3 dimensions, an object has. So that's going to be, guys, you gotta get your glasses. I'm just kidding, it's just these images, but the rest is going to be in normal images. Well, for example, we have here a cube that is made up of small boxes, as you can see. And this big cube is going to be of 3 meters times 3 meters times 3 meters in the length of the edges. And this cube is going to be filled with these small boxes. Each box has a length of 1 meter times 1 meter times 1 meter. So that means that if you have all of these boxes inside this big cube of 3 meters times 3 meters times 3 meters, you're gonna have 27 of those boxes inside of this big cube. How do we know that? How do we know that we have 27? Well, we can count them, but we can also do the following reasoning. On the base, for example, this part, on the floor, how many boxes do you have resting on the floor? You got 3 on this side, you got 3 meters here, and you got 3 meters here. That's telling you that you have 9 of them. If you take all of the boxes out, well, it's going to look exactly as you can see on the top. You have 1, 2, 3, 4, 5, 6, 7, 8, and 9. You got 9 of them on the base, on the floor. But you have 1, 2, 3 of these layers. So you have 3 layers of 9 that gives us 27, which is the same as just multiplying 3 times 3 times 3. That's why we have to do this operation in order to get the volume. And it says 27 cubic meters. That amount tells you the volume. It says that you have 27 of these small boxes of 1 cubic meter, and that's how we measure the volume. Now we have here another example of getting the volume of a cube with edges of 6 inches. The edges means what's going to be the length of each corner, or well, it's not corner, it's each edge. It's this length. This is the edge, this is another edge, and all of the edges are going to be exactly of 3 meters. So you have many edges in the cube, but all you want to know is going to be the width, the length, and the height. And since they are all the same, you can just multiply it by 6 times 6 times 6, which is expressed as an exponent, 6 to the power of 3, because you got 3 numbers that are exactly the same. And that's why the formula for the cube is going to be the edge to the power of 3. And the answer here is right there. Alright, let's continue with the prism. This is a prism, as you can see. Well, it's pretty much the same deal. You gotta multiply the length times the width times the height. And in this case, we got a length on this side of 5 units. We don't know if it's inches or meters. We're just gonna call them units. It's pretty, um, it's all relative, right? I mean, if we place inches, it's gonna be having pretty much the same image. It's all relative, okay? But what matters, guys, is that we have this unit of 5 units, and I mean this length of 5 units, and we have 1, 2, 3, 4, 5. And on this breadth, or this could be called the depth or the width, it's all relative again. This part, it's going to be of 2 units. And these 2 units, this means that you have 2 times 5. On the bottom you have, as you can see, 10 boxes. You can count them on the top because you can see them. You can see the face on the top. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You got 10 boxes on one of these layers, but you got 3 layers, so it's going to be 10 times 3, and that's going to be 30. Let's continue. Well, we got this problem where many times you're not going to see the image. They're going to tell you a phrase like this one. They're going to give you a phrase like this one. And you're going to read it, and it says rectangular prism. When it says prism, you know you got to have the length, the width, and the height. Then you multiply that, and that's going to be the amount. Let's continue. So we got this, guys, which I also want to talk about. It's going to be about the units. For example here, what if we have a cube that is 1 foot in length, 1 foot in width, and 1 foot in height, which means that all the edges are of 1 foot. So that means that in 1 foot you got 12 inches. Now remember that 1 foot has 12 inches, right? The question now is going to be, how many cubic inches do you have in 1 foot? What's that gonna be? Well, on one layer you got 12 inches on this side and then 12 inches on this side, which means that in one of these layers, let's say for example this is a loaf of bread, and one of these things is a slice. One of those slices is going to be of 144 cubic inches, because you got 12 inches and then 12 inches here. 12 times 12 is 144. But on this loaf of bread, you got 12 slices. So you got to multiply what's going to be the amount of volume in one of these slices times 12. So it's 12 times 144, because one one slice of bread is 144. One slice. And you got 12 slices on this loaf. So that's why this cube of 1 cubic feet, it has 1,728 cubic inches. That is the amount of cubic inches in 1 cubic feet. And that's why we're also going to have problems of conversions. For example, here we have 1 cubic foot. We know that in that we got this amount in cubic inches. And a similar reasoning is going to be used to get the amount of cubic feet in 1 cubic yard. Because you remember that 1 yard has 3 feet, right? So if you have 1 cubic yard, you got 3 times 3 times 3, and that's going to be 27 cubic feet. And we got some examples here. We got, what if we have 3 cubic feet and we want to change it to cubic inches? What do we do? Well, we know that 1 cubic foot has that amount of inches. So all you have to do is just multiply the 3 cubic feet times the amount of inches that you have in 1 cubic foot. You got to multiply it, and then you get that amount. That's going to be how many little cubic inches you have in 1 big cubic foot, actually in 3 cubic feet. And then we got this other example where it says 162 cubic feet. You want to change it to cubic yards. Now the feet are smaller than the yards. So also the cubic feet are going to be smaller than the cubic yards, which means that you want to know how many times the cubic feet fit inside the cubic yards. That's why you got to make the division. So it's going to be 162, because we got 27 cubic feet inside 1 cubic yard. You got to divide that by 27, and then you get 6 cubic yards. All right, let's continue. We're going to talk about another shape which is very familiar to you, which is going to be the pyramid. And where do you see pyramids? You know it. You know it. Of course, we got the Egyptian pyramids. How do you get the volume for this thing? Well, it's going to be basically the same as the prism. You need to know the length, the width, and the height. But it's not just any height also, guys. It's not just any height. For example, there's also a slant height, but that's not the one that we're going to talk about. The slant height, it's like, what if you go from the bottom of this pyramid and then you start walking on the side all the way to the top? That's going to be the slant height. But if you open the pyramid, if you're on the top and then you open this part of the pyramid and suppose that it's empty, and you let a rock fall inside the pyramid, it's going to take a trajectory like this. It's going to fall all the way down. That's going to be the height that we're talking about. And the formula is going to be pretty much the same as before, as I said, the length times the width times the height, as you can see here. But then at the end, you got to divide by 3. That's the way it's going to be. You got to divide by 3. It's the same as the prism, but divide by 3. And then that's it. So we can also do it like this. 1/3 times the length times the width times the height. And then you can do some cancellation if it's possible. For example, here the length is 15. We know that it's divisible by 3, the 15. 15 divided by 3 is 5. And then you multiply it as a regular prism formula. That would be a trick if you want to follow it, or you can just multiply the length times the width times the height. And then at the end, divide by 3. It'll give you the same result, but with a smaller. The multiplication, you're gonna be handling smaller numbers, but it's up to you if you want to use cancellation or not. Now let's go to another shape, the cylinder. Where do you see cylinders? They're pretty much all around you. For example, that coffee mug that you're drinking right now and your breakfast, that's a cylinder. And also, who can forget the toilet paper? That's also a cylinder. How do you get the volume for a cylinder? Well, as you can see here, it's pretty much the same as the area formula for the circle. As you can see, it's pi times radius squared. That's the area for the circle, but you gotta multiply it also by the height. That's it. So this means that you have pi times radius squared that tells you the area of, imagine that this is a huge cucumber, or a cucumber in this shape, and then you slice it in very, very small pieces, and each piece is going to have a volume of exactly pi times radius squared. If it's very small, that's going to be its volume. But you got to multiply it by h because you're going to get h of those slices. Well, if you slice it into slices of 1 inch, each one is going to have a volume of pi times radius squared. And then you multiply it by 16 because you got 16 of those slices. That's going to be then the volume. That's why the formula is like that. It's going to be the area of the base, which in this case is a circle, times how many of those slices you have. Alright, and you guys know how to do this. Now let's go to another one. Let's go to another shape, which is also very common that you guys see a lot. We call it the cone, like this one, delicious. What's going to be the volume of such cone? What do? You know, it's pretty much the same as the previous problem. It's pi times radius squared because it's basically a cylinder, but it's cut into pieces. It's a cylinder that you had to slice it very carefully to form a cone. And it's pretty much the same as the volume of the cylinder, but you got to divide by 3. And if it's possible, you can also do some cancellation. In this case, we got r squared, which in this case it's 6. 6 inches to the power of 2, it's going to be 36. That 36, we know it's divisible by 3, so you can do that. You can divide by 3 and it gives you 12. So now all you have to do is just multiply 12 times 10, multiply by 3.14, and so on. That'll give you your result. That's pretty much it. Alright, let's do this following problem. Let's say, for example, they say that we need to get the volume of a cone with a diameter of 4 inches and a height of 9 inches. How do we proceed to solve this problem? Well, the formula for the volume of the cone has the radius, not the diameter. So the procedure is going to be get the radius from the diameter. We know that the radius is the half of the diameter, so we use this formula. It's going to be the diameter divided by 2. The diameter is 4 inches, so you got to do 4 divided by 2. That gives us 2. So you got to use this formula. It's going to be 2 to the power of 2, 4 times 9 times this amount, and then divide by 3. As you can see here, you can also do some cancellation because I know that this 9 is divisible by 3. So the 9 divided by 3, I divide that first, gives us 3. I can do 3 times all of this if you want. Alrighty, so that's pretty much it. I wish you a very good day. I'll see you later.